Hi. Just to let you know, if you don't know, this man is called DuFresne. He works at Abelara in the United States, and he's an expert systems integrator, and also a very good storyteller, and also one of our partners. And he's an expert in this field. Despite being younger than me, he's already an expert in this field, actually. And we really like to connect, and we like the way that he's able to help us develop our product and show it off. So today we have a very short, brief demo. Yeah. What's the topic?
UNS.
UNS. Pure and simple.
Pure and simple.
Right. I'll just like to take it.
Okay.
Thank
Sounds good. So there should be other videos. We did some other sessions, and you probably all have gotten some various form of a demo or are going to. So we'll just go straight into the UNS side of this and follow up with the other stuff, or look at another video that's been posted for the details of the platform itself. But we'll avoid the sales pitch for this one. So the big one is going to be on the UNS side of things. Typically, when we're getting started, the first thing we have to do is find some data, find our controllers, find our PLCs, whatever that happens to be, and connect to it and get that data flowing anywhere to start with. And I am in your way. Let me get out of the way. There we go. So the first problem is, where is the data? Where does it come from? And what does it look like? Who programmed it? What did they decide it was? What are the units of measure? What does it even mean? And how is it formatted? Typically that comes in the form of PLCs on the manufacturing side here. And the PLCs are going to have tags or symbols or objects that are defined by whoever programmed it, however they wanted to program it, because that's how they did it. And whatever the last guy decided they liked is what's going to be there. And the first thing you have to do is oh, all right. Screen is stable now. All right. So the screen is stable. The broker's stable. We're good.
The broker is more stable than the screen.
Yes, it is. So yeah, we have random data in the PLCs. We don't know what it means. We got to connect it. We're going to get it into a broker, but it doesn't mean anything yet. It's messy. It's unstructured. It's just what it is. This happens to be a virtual factory that was a life science application, for example, in this one, back from the Prove It conference. And here we have a bunch of random tags. It happens to be in an MQTT broker, but it's structured and formatted in a way that very consistent with the messiness of a typical PLC. So we have a bunch of data here. Doesn't really mean much. It's inconsistent. If we were going to write rules about it, every single tag would need its own rule and its own path, and that isn't very efficient. So the first thing we have to do after we have connected to the devices and started to collect the data is make it mean something. And in this scenario, I'm showing you the results here first, but we took all that unstructured data you saw using Coreflux's modeling capabilities to get consistent tags and consistent JSON packets for that data that every single piece of equipment now has its various sensors and its devices, and whether it's a pump, whether it's a temperature sensor, whether it's a valve, it all has the same payload format now. And then from there, we're able to store it into a time series database, a historian, in a consistent way that everybody can utilize in a normalized structure from there, which we can start doing aggregation. We can start doing use cases off of that require data to be clean and consistent. And how we did that, really, and we'll show you the database just to prove that it's there, is we have the database storing some time series data, and we're publishing it back out on aggregates for the equipment. Yeah, so like here now we've got min-max every hour, every 15 minutes, every 5 minutes, whatever the data science team decided they needed. And yeah, that's just kind of the main story there. So once we connected, collected everything, we started storing it in a database. And not only did we do the connect, collect, store, we kind of normalized it, pre-processed it to make it a consistent, usable data structure at the edge. And getting into how we did that is you've got Coreflux. And we just looked at the data viewer here. It's basically their version of MQTT Explorer for their own broker. We have connections, routes that they have defined. We got the virtual factory bridge, so we're actually bridging the data from one MQTT broker into this one to have that raw data. This is where you'd see your PLC connection or anything like that. And QuestDB is the database where we're actually storing everything and using that. And that's all we have right now. We have an AI agent that's helping understand the models. We can talk to it, ask questions and all that, but that's a separate piece. And then where do we define these models? What does this look like? What does this mean? That's where we have in the user interface here on the low code side, we can define models almost as files that we can edit as we need to. More low code style tools are coming soon. But for the more developer focused people who want to get a little bit deeper and more technical and work with it how they work with it, there's also a VS Code extension that allows you to define all of those routes, those connections, those models, and things of that nature on top of it. And from the sake of the UNS, that's where this demo kind of ends, just kind of getting everything clean. This is kind of a very quick overview on where and how to get started. So if you have nothing, it's a free download, all that, and there's no sales pitch, so I'm gonna stop going down that path. But that's where it comes in. And what we didn't talk about is after I've connected, collected, and started modeling and contextualizing my data, the next steps are what do we do with that data? And that's where they have actions, expressions, functions, things like that we can run in the broker. So we can run machine learning algorithms, we can run the agents, we can run Python scripts that we write and all that. But that's after we've done our connect, collect, store. Now we can start to analyze that data, identify the use case, solve the use case, find the next one, solve it, find the next one, and iterate over time to start solving the problems. Yeah, went quick through that. So if I spoke too fast or if people have questions, let me know. Yes. So in this demo specifically, it was already in an MQTT because that was the data source. But in the real world, it would likely either be a connector to the OPC server or an existing thing of that nature, or the routes they have. I keep calling their routes connectors. So their routes include things like Step 7, Ethernet IP, and Mitsubishi coming soon, things like that. So it'll be using the, yes, spoiler alert. You might have to cut that. But yeah, it's got native PLC protocols. It'll do pull rates, you set up those routes, bring the data into the broker, and then, yes, so Coreflux has those connectors. Most of them, if not all of them, are available in the free tier.
The one that we're currently working on for industrial purposes, it's not yet available directly, it's SparkPlug.
Yes.
Pretty much everything else is already.
But that said, it is a broker, so if it has SparkPlug B, which they're adding that way to break that out soon, but it's still a broker, you can send it over it, no problem. If the PLC or the device happens to support it, you can send it right to the broker. REST APIs, you can have routes where you get the data from a REST API or send it to one. You can send data back to the PLCs. That's kind of the route. Huh? Video streams too, yep. Yep. So anyone who wants a more detailed demo of a lot more of these extended functions, they're all running back there on those screens as well. So we can definitely get that going. Thank you. Good to see you.
Thank you.
Thank you.
Thank you.